Question, it is given two spheres, each of mass m, each moving with a velocity u, moving in the directions at 30 degrees south of east and 30 degree north of east respectively, collide at a point O and they stick together. The velocity of the combination later becomes. So to understand and solve this question, okay, we need to know about the directions. So one thing that we know is they are sticking together, which means it is a perfectly inelastic collision. So in that case, what we will do, and it is a two-dimensional collision. Okay, so this the way of representing the direction, you need to understand how or what it is, right? So first, let me draw the directions. So this is the north pole, this is east, this is south, and this is a west. North direction, east, south, and west. Okay, so then the first particle is traveling south of east. Okay, so what is the meaning of south of east? So first you take east, from there, you move towards the south at 30-degree angle. Okay, because that is given in the question. So this is south of east. So you take east, from there you move towards the south. Okay, so this direction is the south of east direction. Similarly, here we will take east, from there we move towards the north. So that is north of east direction. So this is north of east and this is south of east. Okay, both of them are at 30-degree angle. So the first particle is traveling in this direction and the second particle is traveling in this direction. Okay, and they both collide at this point O. So they both collide at the point O, and when they collide, what happens is the two bodies, they stick together and they move with a common velocity. So we have to find that common velocity and the direction of that velocity. So what we will do is we will resolve the velocity into two components. Okay, so the first particle is having u cos 30 here. So this is 30 degree and here you have u sine 30 degree. Okay, so this is along which direction? Positive, the north direction. So let us take it as j cap, and this is along the I cap direction. And the second particle also we can resolve into two components. So this is 30 degree, this will be u cos 30 degree into I cap, and then this side you will have u sine 30 degree into minus j cap. So this is in the negative south direction, which is minus j cap direction. Okay, so applying the law of conservation of momentum, because in all types of collision the momentum is definitely conserved. So when we apply it, we have to apply separately for x-axis and separately for y-axis. So first let us apply for the y-axis. So the total momentum before the collision, okay, total momentum before collision will be m1 mu sine 30 into j cap plus mu sine 30 into minus j cap. So clearly you can see this is going to add up to 0, which means the total the momentum along the y direction is going to be 0. The particle stops to move along the y direction after the collision. Okay, so then along the x axis, so what are we going to get along the x axis? That is mu cos 30 degree into I cap plus mu cos 30 degree into I cap is equal to, both the particles are moving with a common velocity, therefore m plus m into v. Okay, so let us say this is v vector. So we have to find this v value. So what we will get? We will get 2m u cos 30. What is cos 30? It is root 3 by 2 into I cap equal to 2m into v vector. So m and 2 will get cancelled. Therefore, v vector is equal to root 3 by 2u into I cap, and I cap here represents due east. Therefore, the correct option will be option A.